Modernage MCQs, Physics first year, Unit number 6, Fluid Dynamics, Part 2. The maximum drag force on a falling sphere is 9.8 Newton. Its real weight is option A 1.0 Newton, option B 9.8 Newton, option C 4.9 Newton, option D 0.0 Newton. The key is 9.8 Newton. Therefore, the correct option is B. Reason: when sphere falls, the drag force increases due to increasing velocity because the drag force is Fd is equal to 6 pi eta Rv. As the velocity increases to its maximum value, terminal velocity, the weight of the body is balanced by dragging force. Therefore, the dragging force Fd is equal to mg is equal to 9.8 Newton. Hence, the dragging force is equal to weight is equal to 9.8 Newton. Extreme turbulent flow is observed in option A, rivers, option B, pools, option C, vessel, option D, tornado. The key is tornado. Therefore, the correct option is D. Reason: the tornadoes are violently rotating columns of air. The tornadoes extend from thunderstorm to earth and make heavy destructions. Hence, tornadoes are examples of extreme turbulent flow. At terminal velocity, the acceleration of a falling rain droplet is option A is 0 meter per second, option B 4.9 meter per second, option C 9.8 meter per second, option D 19.6 meter per second. The key is 0 meter per second. Therefore, the correct option is A. Reason: the terminal velocity is a constant velocity. The net force acting on a falling rain droplet with terminal velocity is 0. Therefore, F is equal to ma gives 0 is equal to mar. A is equal to 0 because m is not 0. Hence, the acceleration of a falling rain droplet is 0. The volume rate of flow of a fluid through a pipe of area of cross-section A with speed V is equal to option A, V divided by A, option B, A divided by V, option C, AB square root, option D, A into V. The key is A into V. Therefore, the correct option is D. Reason: the product A into V is equal to A into delta X over delta T, which is equal to A delta X divided by delta T, which is equal to delta V divided by delta T, which is equal to volume rate of flow. Hence, the volume rate of flow is equal to A into V. If A into V is equal to K for a fluid flow through a pipe of area of cross-section A with speed V, then constant K will be option A, volume flow rate, option B, density of fluid, option C, mass of fluid, option D, volume of fluid. The key is volume flow rate. Therefore, the correct option is A. Reason: the product A into V is equal to A into delta X over delta T, where delta X is the distance traveled in the pipe through the time T, which is equal to A into delta X divided by delta T. The product of the length and area of cross-section is equal to volume. Therefore, it is equal to delta V divided by delta T, which is the rate of flow of volume through the pipe, which is equal to Kr. K is equal to volume flow rate. Hence, the constant K is volume flow rate. An ideal fluid flows through a pipe of area of cross-section A1 and A2 with the respective speeds V1 and V2. Then the ratio is A1 divided by A2 B square root A2 divided by A1 C A2 divided by A1 D square root A1 divided by A2. The key is A2 divided by A1. Therefore, the correct option is C. Reason. From equation A1 V1 is equal to A2 V2, which is equation of continuity, we have V1 divided by V2 is equal to A2 divided by A1. Hence the ratio of speeds is A2 divided by A1. An ideal fluid flows through a pipe of area of cross-section 4 square centimeter and 8 square centimeter with respective speeds V1 and V2. What is the ratio V1 divided by V2? The option A 1 to 2, option B 2 to 1, option C 4 to 1, option D 1 to 8. The key is 2 to 1. Therefore, the correct option is B. Reason. From equation of continuity A1 V1 is equal to A2 V2, we have V1 divided by V2 is equal to A2 divided by A1, or V1 divided by V2 is equal to 8 square centimeter divided by 4 square centimeter, which is equal to 2 by 1. Therefore, the ratio is V1 to V2 equal to 2 to 1. Hence, the ratio of speeds is 2 to 1. The speed of water in 4.0 centimeter diameter pipe is 5.0 meters per second, and it enters 6 centimeter diameter pipe with speed. Option A 4.0 meter per second, option B 5.0 meter per second, option D 6.0 meter per second, option D 9.0 meter per second. The key is 5.0 meter per second. Therefore, the correct option is B. Reason. The speed of water at every point in 4 centimeter diameter pipe is 5.0 meter per second. It is also 5.0 meter per second just before entering into 6 centimeter diameter pipe. After entering into 6 centimeter diameter pipe, the speed decreases according to the equation of continuity AB is equal to constant. Hence, the water just enters with speed 5.0 meter per second. The speed of water in first pipe of 6 centimeter diameter is 5 meter per second. It flows into 8 centimeter diameter pipe. What will be the speed of water in second pipe? Option A 8.0 meter per second, option B 6.0 meter per second, option C 5.0 meter per second, option D 2.8 meter per second. The key is 2.8 meter per second. Therefore, the correct option is D. Reason. From the equation of continuity A1 V1 is equal to A2 V2, we have V2 is equal to V1 into A1 divided by A2, which is equal to 5.0 into 2 pi R1 square divided by 2 pi R2 square. RV2 is equal to 5.0 into D1 square divided by D2 square, which is equal to 5.0 into 0.06 whole square divided by 0.08 whole square, which is equal to 5.0 into 0.36 divided by 0.64, which is equal to 5.0 into 9 by 16, or V2 is equal to 2.8 meter per second. Hence, the speed of water in second pipe is 2.8 meter per second. The equation of continuity for an ideal fluid is derived from the conservation of option A energy, option B mass, option C volume, option D pressure. The key is mass. Therefore, the correct option is B. Reason. For the flow of an ideal fluid, the mass of fluid at every point of a pipe remains constant, or we can say that the mass entering at one end of a pipe is equal to the mass leaving from the other end. Hence, the equation of continuity for an ideal fluid is derived from the conservation of mass.